So this afternoon, so good afternoon, by the way. So I'm Kaushik Ghosh in Pierluca's team. Like I guess Pierluca said, I'm responsible for the Unity and the SC, the roadmap, the strategy. So we're going to talk today, but we're going to talk today only about the SC. Like Pierluca said, at Storage Field Day 13, we did a review of Unity in depth. So today we're going to talk about the SC. Now, for those of you who were here 2010, you will see some of the feature functionality we talk about today is sort of similar. That's not a bad thing because that basically tells you that some of these features are pretty mature, unlike what our competition is offering right now. I mean, these products have been there, tried, tested, and basically we have worked on top of it, providing additional new capabilities, right? So that's like you would go there. So with that, so this is basically what our mid-range portfolio has. Now there are other products that we have on an N-1 products that we still sell, but these are our lead horses in the mid-range space, right? So that's basically the Unity line, and then the SC, which is the compellent, formerly the compellent line, right? I don't know if you saw the announcement yesterday. We launched a brand new SC Allflash, right? Not a surprise given where the industry is going with Allflash. Pretty much all of the rest of the Dell EMC portfolio already had Allflash flavors, right? Unity launched, when we launched, we brought Unity Allflash. Isilon has Allflash, VMAX is Allflash, XtremIO is already Allflash. So it was just a matter of time when we had to come out with the SC Allflash, right? So that sort of completes our Allflash portfolio. Now everything has an Allflash flavor, and adds that.
Is the SC or Flash any different to the SC that you've been selling with Flash in it before, or is it just a Gartner tick box that you can't put spinning disk in it?
Oh, good. Somebody else complained about that.
So right now, from a hardware perspective, it is similar. But from a packaging perspective, and I'll talk about it, is different, right? So for example, one of the things that all Flash customers have been asking about is we want everything included. I don't want to buy separate software separately. So you'll see that included. You'll also see from a software capability promotion perspective, like for example, when you buy a Unity Allflash, you get a free cloud with it, right? And we're going to offer the similar capabilities on the SC Allflash. When you buy it, you get a certain amount of capacity free on our Dell EMC cloud supported by VirtuStream, right? So yeah. So that sort of is a good segue, because what I wanted to tell you is that even though we have two products in mid-range, there are some unique capabilities in each one of them. I'll talk about a little bit about what's unique among each of these capabilities. But so we're not going to replace one with the other, right? So that's something I want to make sure everyone understands. Each one has their unique capabilities, so we're going to continue to invest in both products, right?
For how long?
Or till we end of service life these products, right? End of life these products. So till the life of these products, we are going to continue to invest, continue to offer these two products. But where we are going to bring things together is in the ecosystem, right? So for example, from a sizing perspective, earlier when the companies merged, we had two separate sizing tools. Now it's all merged into one, right? When last year on the Dell EMC, on the Unity side, we introduced Cloud IQ, our cloud-based monitoring. Now that's Cloud IQ is now supported on the SC. So you have one single pane of glass through which you can monitor both mid-range platforms, right? We have recover point-based replication between Unity and SC, right? We have PowerPath support, vPlex support, right? So on the ecosystem, AppSync support is coming soon, right? So on the ecosystem perspective, you'll see all of these things coming together.
Okay, is that recover point built into both platforms or external appliance?
So the splitter is built in. The appliance is still external that you do need.
Yes, right. We offer a recover point for VM.
Also,
well.
yes, yeah. That is correct.
Yes.
Okay.
One's more impressive than the other.
Yeah.
Yeah.
So your opinion. It's good.
Well, my opinion about which one.
Yeah. Correct. Another thing, Kaushik, so we built this ecosystem, but now we're going to change also the experience on the product. So someone was asking, we're going to give you a preview of, for example, the next Unisphere. So we bring in Unisphere also on the SC line. So we're going to give you a preview of that. That's very important because the look and feel will be the different. But obviously, the products are different. So we don't want to replace with the same Unisphere. It's a look and feel that the customer can experience. And the other part that Kaushik was pointing out, Cloud IQ really broader this ecosystem with the proactive health. So we can have proactive health in the cloud and automatically tell you which action you need to take to, we have an health score, to make that score better on the SC or on the Unity. So that's allowed the customer to actually use, as we want, this system in the right use case, right? So we have a bunch of different customers that they use both, right? So that's very important, I think.
Yep, thanks. So quickly, should just give you a quick review of the business before I go in deep dive into the technology. This is just from May last year. That's the time when we launched the Unity platform. As you can see, we have done really well. If you look at just Unity and SC, it's $2.3 billion. 35,000 systems have been shipped since that time frame, right? With 20,000 plus customers, right? So a pretty solid portfolio that we have right now. Right, as you can see, a lot of customers, a lot of enterprise level customers also, not just any, right? So solid portfolio that we have right now with these two products, right?
Wait. She's taking a piece.
Oh, sorry,
That's
I
it,
didn't
it's okay,
realize.
it's okay.
So both products are mid-range products. So what that means is from an architecture perspective, at a very high level, 10,000 feet level, it looks similar. Like they are both dual controllers, both serves block I/O extremely well, very reliable products, rich data services, and so on. But if you go a little deeper, there are some unique capabilities in each of these products, right? So for example, on the Unity line, it's all inline efficiency, right? Inline compression, zero detect, deduplication coming soon, right? So everything is inline. SC, on the other hand, we call it the intelligent efficiency, where we first acknowledge the I/O, and I'll walk you through how it works. We acknowledge the I/O first, and then our process kicks in where we compress and dedupe it. Right now, the advantage of this is that basically, this technology works not only with Allflash, but you can also work with hybrid, and also the fact because it does after the fact, we can get you a much deeper, much better efficiency than I would get, say, typically with an inline equation, right? So that's a key differentiation advantage on the SC side. The SC is also federated, so even though it's a dual controller machine, you can start with one, and then you can add multiple machines and manage it all together with the Dell Storage Manager as one unified cluster, and be able to move the LUNs around, which is what we're going to do demo today. Move the LUNs around transparently.
One LUN lives on one array, right?
That is correct. That is correct. Absolutely. So that's the federation side of it. Unity, on the other hand, is unified, right? So you can have file, you can have block, you can have vvols, everything together. There's also a software-defined option, so you can buy it as an appliance, you can buy it as a software-defined, or you could buy it as a converged VAV block that we offer.
And on that comment, right? It's one LAN, yes, but again, this is mid-range, right? So.
Oh, no.
We want to use the portfolio, right? You listen about VMAX and Extreme I/O, and so that's why it's federated. I know. I want to clarify.
I understand. And just remember, we're just trying to clarify. Yeah. We're not
Absolutely.
making value judgments.
Yeah.
So
yet.
Don't yet. When we are making value judgments, we'll let you know.
Absolutely.
And do it, please.
You should know me well enough by now.
Yeah, I know
Jason
that.
certainly does.
And then moving on, the Unity has one of the key things that we have. When we met last time, we talked a lot about is this hybrid cloud integration, right? Customers going with cloud, trying to decide, should I go with cloud, should I go with on-prem? What we are saying is, no, you don't have to make that decision. You can do both, right? And we offer the not only the technology, and what I'm going to show you later is we also offer you the cloud part of it free today with VirtuStream to customers. So you get the cloud, you get the on-prem. We have the tools that integrate, so you don't have to make a decision between this or that. It's an and conversation.
Okay, are we going to come back to the Federation?
Yes.
We will talk a lot about the Federation.
And we're going to
yes.
have also a live demo.
Yeah.
And then there's the demo that we're going to do, right? And then on the SC side, one of the value prop is on the economic side. So just from a pricing perspective, we have a very attractive price. The dedupe and compression gives you, on top of it, a lot more efficiency. As I said, the dedupe and compression works not only for Allflash, right, which is what most of our competitors does, but it can also work with hybrid because of this technology, right? Many of our competitors only offer dedupe compression on Allflash.
There are issues with reading deduplicated data from spinning disks because there is IOP amplification inherent.
Right. Plus the issue, what happens is when you're doing inline, right? Say if you have nearline SAS behind it, right? IO is coming in. You have to quickly process it, send it back down, right? If your disk is slow, then that automatically creates a bottleneck, right?
That's less of a problem because I can address that with a log and a write and free space file system. It's when I try and sequentially read data that's been stored on deduplicated spinning disks.
Yeah, right.
Then I make one megabyte IO request, but it's not one IOP to hit the disk.
No. You're right. You're right.
And it's fine for colder data, and
That's correct.
And a lot of vendors are just ignoring.
And that's why how we position it, right? So I don't want to put and that's where when we're gonna go in the deep dive of the architecture, you're gonna see how compellent understand that skewing of the data and the data decay model.
Is that selective? Can I apply it to some LUNs and not
That is
others?
correct.
Yes,
that is absolutely correct.
Yes.
That is
And you can create different
Okay,
domains.
then I like it.
Yes.
And
That is
most of the
absolutely correct.
competitors avoid dedupe to spinning disks because the occasional customer will do stupid things and get lousy performance.
That is right. And we also offer you flexibility in the sense like, one, basically you can turn it off. If you do turn it on, you can decide, do I want only compression? You could decide like, this is not deduplicable workload, so I'll just use compression, which a lot of our customers do. And then you could turn on both compression and dedupe, right? So that you get that flexibility. All right, so before I go into it, there's one last thing I just want to highlight. So this is also something that came out as part of the announcement. So apart from the awesome product that we have, we also came out with a awesome program to go around with it, right? Offering some capabilities that's pretty unique today in the industry, or for the maybe first time that we are offering it. So the first one, I'll just quickly go over these. So the first one is a 3-year satisfaction guarantee. So the important thing I want to highlight is the 3-year part. That's no one in the industry today does a 3-year satisfaction guarantee, right? So so it's 3 years. If the product doesn't meet the specs that we say it should, then we will either fix it, we will repair it, or if none of those things work, we'll give you money back. The second one is the Allflash storage efficiency guarantee. This has been there, but we sort of rolled it into the Allflash portfolio now. So it's a 4-to-1 Allflash storage efficiency guarantee. No assessments needed. So this is basically will give you guarantee pretty much to any customer who wants this guarantee. Right, and of course, what we have seen in-house, you can actually, depending on your workloads, we can actually do much more than this 4-to-1. Like this is just the baseline guarantee that we.
What are the caveats to that then?
Yes. Yeah.
Yes, there are. So
Obviously.
No, I said, what are they? So what are the caveats?
So that's include the fin, snap, and also obviously the caveat is the workload need to be compressible and dedupable.
So you're including snapshots in that guarantee, in that 4-to-1?
Yes.
Okay.
right.
Well, of course.
Okay.
So remember, it's the guarantee.
Let me.
No, I know.
I know why you asked this. So we are actually looking to, because we are above the 4-to-1 actually guarantee is across different products. Is not only on the mid-range product, right? So that's why we taking a step back and we say it's 4-to-1 for everybody, right? So we need to be sure that it's 4-to-1 across the board.
I don't blame you for doing it. I wouldn't want to be giving away
But
stuff.
but we are looking to actually look into how we can make this specific to the technology that we use, right?
Yeah. No, my only thing about that is that there's a difference between 4-to-1 from an efficiency guarantee perspective, and another for when you're actually quoting systems out and sizing them for customers and
Yes.
quoting efficiency, right?
Absolutely.
That is
So we're not talking apples to apples on those
right.
things, but
That is
so
correct.
you're
Yes.
kind of saying two different things to customers when you do
So
that.
actually, for the use case where the customers say, especially we have large customer that they know their data set, we run actually a tool to estimate the things, like all other ones they doing.
Yeah.
And then we stand behind that guarantee that is specific for that workload,
Yeah.
right?
Yeah,
And
no,
this
don't
is a generic.
Don't feel, we've banged other vendors on the same exact thing just as hard.
Yeah. No.
And it's good. That's good.
So moving on.
Equal opportunity curmudgeon.
So moving on, one of the other things that we also make a guarantee on or make a commitment on is this something called never worry data migration, right? So you'll see me talk about it in this presentation today. On our SC line as well as on our Unity line, we have built-in tools to migrate data, in some cases online, from our previous generation. So if you have a VNX customer, you have a VNX array, you can move the data transparently in some cases into the Unity. Likewise, if you have a Ecologic, you can take data from there and move it into the compelling. And what we are saying is that moving forward, when we come up with our next generation product line, we'll offer the similar capabilities and everything online day one. So if you have a SC series product, or if you have a Unity series product, our next generation, you will be able to do an online migrate from those two products to this next generation product. So that's basically the commitment. So it's not just N-1 to today, but even into the future, we will be offering you these online migrations.
How do you do the PS to SC migration?
We offer PS to SC migration. I'll talk about that in the presentation today. Okay. And it's not just PS. We also offer MD. We also offer a whole bunch of other products as well. So I'll talk about that when. The fourth piece is a hardware investment protection. So this is just saying that, hey, if you have an existing Dell EMC product, you can trade it back in. We'll get a credit when you trade it back in and buy a new Unity or a new ASC product. So not only will be able to migrate the data, we'll also give you a credit for that hardware that you already have if you trade it back into us. Okay. All inclusive. So that's on the Unity side. We were all inclusive. Now with the SC, now is also becomes now all inclusive. So when you buy the product, all software that we show you is all included. Plus, not only that, in future also when we release any software, those will also be all included, right? So you never have to worry about buying a piece of software in future.
Hybrid and Allflash versions of SC, yeah?
So right now the all-inclusive on SC is only for Allflash. On Unity we do offer it for hybrid and Allflash, right? So it's we'll definitely take a look into on the hybrid side as well. And then the last, yes.
On the hybrid side, are you continuing what Compellent used to do and not making me rebuy the software when I upgrade?
Absolutely.
Yes.
So the thing that you're talking about is called persistent license. So yes, on the hybrid, that's actually one of the reasons why we haven't offered the all-inclusive yet, because if someone has bought a persistent license, you might say, hey, why is there's some challenges there, let's put it that way.
Yeah, well, it ends up raising the cost for the existing customer.
That is correct, right? So that's the reason, I didn't go into it previously, that's the reason we don't have it on the hybrids yet, but we're looking to figure out how.
Yeah, but that from Compellent, that was really the first of the trend that
Right.
we're now in with things like Pure's Evergreen, where the
Yes,
buying cycle is
right.
just
Correct.
completely different.
Absolutely, right. So, and then the last piece of it, not the least, is what we introduced it recently with Unity, is we have, Dell EMC is one of the only companies which offers both an in on-prem as well as a public cloud solution, right, through VirtuStream. So we are now, if you buy any Unity Allflash as an example, we will give you 20% of that capacity for free on VirtuStream Cloud. Right now this is only available on the Unity Allflash. We will be offering this on the SC Allflash beginning of next year.
Okay, and in VirtuStream, that's storage to run VMs on, not object storage, right?
No, this is the object storage.
That's the
So
object
this is the S3
Yeah.
storage. So the use case is basically you run your primary workloads on the Allflash, and then any data which is like snapshots which are old, you don't want to keep it around. You will just move it into the S3, and that's your backup tier, right? If anything goes wrong with the array, there is a DR. There, you get a new array, you get all the data back.
You don't need the original arrays and metadata to create.
No.
That is
Stuff
correct.
back?
Yes.
That is correct.
So
you don't
we use a technology that it's a virtual appliance that is a CTA. So we can tier file, but we can also tier the block snap. And you can actually, one of the most interesting use case for our customer today, some big customer that, for example, the CTA also tier to ECS, our local object, and also with the IBM Cloud Safe. One of the most interesting use case, we have customers that are using CTA since a long time.
What does CTA stand for?
Cloud tiering appliance. So what is happening in that case, we use a stub technology. So you can basically retire your old storage and bring in the new storage without rehydrating the data. So that's, you just move the stub that they are 4K blocks. So that's an advantage in that case.
Which
right?
technology is that? That CTA? Where does that come from?
It's come from old EMC. It's called DHSM. It's a protocol that we invented 20 years ago, file mover. The things here that we find out looking at the technology that we can extend that to block. CTA originally was only file. So we are extending that to the SC for block, and we extended for Unity. So that is free because it's included. You don't need to, and it support HA. And you can go, in this case, as Kaushik was explaining, VirtuStream, but it support Amazon and all the other cloud.
Right,
Okay?
right. So the technology supports all clouds. What we're going to offer you as part of the promotion is our own VirtuStream cloud.
You said it was 20% of what the capacity you bought. Is that what it is?
That is correct. Put 20% of the raw capacity. So you buy 100 terabyte of Unity All-Flash, you get 20 terabyte of VirtuStream cloud.
You said that was Unity or Flash only.
That is currently on the Unity All-Flash. The SC All-Flash, we are going to offer it like beginning of next year.
And you, can I just qualify? Did you say that it's only 20% of the capacity of the box, but you said you can re-instance your array if you lose it from that copy?
That is correct. That is
Yeah, you need to buy.
You need to buy extra.
Yeah.
I mean, the free part of it is 20%
Right, okay.
is free.
The razor
Yes.
handle
So-
only comes with one
Yes.
blade.
Yeah.
I think we need.
Yes.
Just want to make sure that's
That
clear.
is
Yeah,
correct.
That's
That is correct.
'cause otherwise
Absolutely
I'm
clear.
still going to do a full
that-
copy of all my data, otherwise I'm not going to get
Is
it.
that
Uh,
perpetual?
20
I mean, is that cloud
Well-
storage forever or
No, no, the cloud.
3
So
years?
let me clarify. So yes, so 20% is what we offer. The 20% is also it is the lowest tier of VirtuStream storage. That's the one we offer for free. So of
Right.
course, if you want to buy more capacity, you pay extra.
Allow me to say, picking 20% of the slowest tier as
Yeah.
the free giveaway is just perfectly giving away the first lollipop to make customers hungry to buy more.
Thank you. Thank you.
All right. Yeah, but how long do you have it for?
1 year, sorry.
So it's only 1 year after you buy the
It is
box.
1 year. So the day you buy the array, you basically from that day, 1 year you get it, 20% capacity for free. If you want to keep it for after that 1 year, you have to pay for it. If you want more capacity, you have to pay for it. And if you want to go for a higher tier capacity, then that's extra as well.
I would have preferred to see it determine the support agreement, but whatever.
Yeah.
But if I've got a 20 terabyte box
Yeah.
and I want to use that as my DR solution, because that's what you implied I could do if the box died,
Yeah.
you're going to give me 20% of 20 terabytes. I've still got to buy a lot more than that in order to re-instance that box, because I need at least a single copy of that entire box in order to re-instance it. I can't do it from snapshots.
That is correct. So there are a couple of things. One, basically, you are not going to fill up your capacity day one, right? So the cloud, you can basically keep buying
I can't re-instance a box that I haven't got all the data for in the first place. I can't do it from the.
No, if you want a full thing, you have to buy.
So for example, let me explain the situation. So you bought a 20 terabyte box in your example, right? Of which, say for example, on a say for example 5 terabyte you have filled up. The remaining is not filled up, right? So you only need to protect that 5 terabyte, right? That 5 terabyte worth of data. You need to just make sure.
You're only supposed to use a fifth of your box, Chris.
Right.
Sorry?
You're only supposed to use a fifth of your box.
Yeah,
Right,
there is
okay.
another.
So the idea is that if I've got an empty box when I first buy it,
Yeah.
then you're protecting or if I only got 5% of my box filled when I buy it, then
It's
you've
the laptop
given me
that comes
20%.
with antivirus on it that you get 3 free months of
So it's a
subscription.
little bit different, actually, sorry, because also we have a compression, CTA support compression
Right.
inline. So there is more space there. Obviously, we not say that you can protect the entire thing. Now, at the beginning, you're going to protect the entire thing. I mean, it's obviously that we need to also to make money at some point on what we offer in Virtus.
I know, there's nothing wrong with that.
there's
That's
a
fine.
cost
I just
point.
wanted to make sure it was clear that
Yeah.
I'm not getting a free backup DR service effectively,
Yeah.
but I am going to be paying for it
Yeah.
in some form.
That is right.
Yes.
That is right. And the other thing is we back up, and you'll see this, we back up the snapshots and the LUN data. So it's not like every data on the box is backed up. So it's not an mirror image of that thing. So the situation, if there's a flood and whatever reason you lose the box, you do have to get a new box. You have to set it up, everything. So those things you still have to do. And then
enough,
the
yeah,
data
yeah.
which is in the LUN and the snapshots, there's the data you can just restore basically from the cloud.
I have no problem with the offering.
Right.
I would say of all the 6 things that are put up on that board, that one is a little misleading. It's because when I look at that, it looks like I'm getting that as part of my box.
No.
And that means I'm going to get it, I'm going to have it and hold and love as long as I have the box. That's not the case. It's a 1-year promotional, sample of Virtual Stream is what you're getting. You're not really getting it. And so, if I start using it and it becomes part of my process, I'm going to have to start paying for it more later, of which I have no idea what that's going to cost me because I don't know what it is, neither do you. And it's fair because there's a cost to it. You guys, I'm not saying you guys need to give it anything away.
Right.
I just think you need to be a little bit more
Clear.
a little more honest.
I think is a good feedback. So we will bring back that feedback.
No problem with the offering.
Yeah.
Sure. Absolutely. Okay. So anyway, so that's that. Moving on. So again, like as I said, we introduced the SEL Flash, right? Great performance, right? This is of course from a single array. Now this is the best case scenario with read-only, right? Now if you federate that, of course you can get much more, but as long as you distribute your workloads, that's not one LUN being shared. So as long as you distribute it, you can scale out.
It's federated, not quite scale out.
Federated and not scale out, exactly, absolutely. And then similarly from a capacity perspective, you can do that. And I'll show you how we do load balancing, rebalancing. We call something called Volume Advisor, which does intelligent rebalancing across this federation, right? So we're going to talk about it, and then we're going to do Jason is going to do it.
And that's one of the part where it's very different from the competition. We're going to show you the volume advisor. You can do different things. It's not only performance or capacity. You can decide what you're doing, and there is an intelligent that's spread across the multiple system.
Right. So if a particular array is getting filled up, basically say, for example, you say based on capacity, it fills up 80%, you can set the threshold. Automatically, you'll get an alert and say, okay, this is getting filled up. Here is another array in your federation that is not used as much. I would recommend you move the LUN out there. So if you say, yep, I agree with it, you just click the yes, and then it automatically moves that LUN, transparent your application to that particular array in the federation.
This is Fiber Channel and iSCSI, correct?
This is, yes, Fiber Channel, iSCSI, everything. We support that.
We're going to show that.
We're going to show that, yeah. Dynamic, so that's basically there's a capability of this ability to move LUNs around for different use cases, right? Whether it's for load balancing, whether it's for migration, whether you're adding a new array, right? Or even for DR, right? So different use cases we can solve with this core technology, this mobility use case, and we're going to talk about it. And then the efficiency part of it, right? So like as I said, the guarantee when we're talking about is just a baseline. Depending on your workload, you can get anything from a 3 to 10x data reduction from dedupe and compression, right? Cloud-based analytics, we talked about Cloud IQ, and then all software included, we talked about it earlier. When we talked about all software, I just wanted to give you a flavor of the different types of software. This is not a comprehensive list, just to show you some of the key software that's included now with the box. When you buy the box, all of this is included. So dedupe and compression, all that's included. Instant replay, that's what we call our snap technology, snap and replication technology, that's included, right? We include data at rest encryption. You still have to buy the key manager, but the encryption part of it is included. We also offer application protection, application consistency. We call it the replay manager, right? So with that, you can take application consistent backups. Cloud IQ analytics. So Cloud IQ, that will also be included with the account. live volume with auto failover. So that's our DR technology, where you can move from A to B automatically failover in the middle of
We're
the night.
coming back to that, right?
Yes.
We are going to talk
Okay.
about some of these capabilities in depth, right? We're going to talk about this, we're going to talk about this, and we're going to talk about the federation.
We're going to talk
piece
about the
of it.
QoS?
Yeah.
Yes.
QoS, we can talk about it, but I didn't have a slide specifically, but if there's a specific question, we can definitely address it or answer it.
Well, they'll be
Well,
Look at it on the demo.
Is it
The fun part.
a throttle or is it more than that?
the minimum or max.
So this is basically minimum right now, right? In the sense like
Minimum?
this is basically, I don't know what.
No, you
I
can't do
mean,
just minimum.
it's not a guarantee. That's what if that's what you're asking.
No. So the entry stakes for QoS
Yeah,
is to say, don't allow this LUN to exceed X IOPS.
that's right.
Yes.
That is
clear.
exactly this.
Okay, so it's
Okay.
a throttle.
Right.
This is throttle. That is right. That is right.
Okay.
Right. So we can do IOPS, we can do bandwidth, latency, right? So
Yeah,
those
no,
type of,
most systems
things.
don't do QoS at all,
Right,
and
right,
so
right.
if you
No,
do throttle,
yeah.
that's a step
That
up.
is right. That's
There are more sophisticated methods beyond that, but
Right. That is
We're actually going to, I'm on. We're actually going to leverage QoS to inject latency into one of the demos, so that volume advisor sees that, hey, we've got latency that just escalated for one of the applications that we have, and then volume advisor is going to make a recommendation in the federation to move that application seamlessly. So
Right,
you'll
I-
actually get to see QoS as part of that.
part of that.
That's
Red
why I
lemon-
And it absolutely is an IOPS limit that I defined
yeah,
that's going to drive latency.
okay.
Okay.
Cool. Yes.
One recommendation for the next rev, have the throttle only apply when the system is stressed.
Yeah. Do you have any? Yeah.
Oh, I understand what you say. So if you reach certain threshold,
When the system is only
Yeah.
running at 15%
Yeah.
of capability,
Yeah.
if I'm a solution provider, I always want to say that guy gets 1,000 IOPS because he's paying for 1,000 IOPS.
Yeah.
If I'm an enterprise guy, I want him to have 10,000 IOPS as long as there isn't anybody else he's stealing them from.
yeah, it's the noisy neighbor.
I disagree with
And
you.
he can be as noise. Well, no, but give him both.
I
give me
don't
both
want
options.
him. I don't want him to ever see 10,000 because then when he gets his 1,000, he's going to complain.
Yeah.
Depends. It depends very much on the application. But
And the interface.
yeah, as it's here's the threshold. Here's the throttle.
Absolutely.
And then say, only when overall latency exceeds this,
Yeah.
should those throttles be applied.
I disagree. Have the option.
All right.
That's good that we have this agreement.
Yeah. No.
You should have the option one way or the other, I
No,
agree.
it depends who the customer is and
Yeah,
what the
no,
and
absolutely.
what the
I mean-
application is.
Right.
Sometimes it's just
Yeah.
like I have a low priority application. I want to run as fast
Right.
as it can, as long as it doesn't bother anybody else.
So you're gonna see in the federation, one of the other things is look at the CPU consumption.
Right.
So that's another way to do it.
Yeah, it's
And there is that logic already in the volume advisor.
right, and so
Your
you just
point,
have to hook
we
the two
should-
together.
Yeah, absolutely.
All right. And then live migrate, we're going to talk about it. Volume advisor, we talked about it. We'll show you again as a demo, and we'll talk enough about it. And then federated management. So this is basically our Dell storage manager today, which we are going to rebrand to Unisphere shortly. And that's basically ability to manage multiple arrays from a single pane of glass, right? And that's where you'll see these capabilities like volume advisor is sitting today, right? So you see all these arrays, you monitor all these arrays, and then decide how you want to rebalance your workloads. All right, great reviews. We just had we had a storage review, did an article just beginning of this year. We were very impressed. Talk about SC, but this is just one article. You can see 20,000 plus customers already bought it, so that's more valuable than this, right? So, but anyway, I would like this stories about the SC product.
How many of those 20,000 customers have deduplication turned on?
Do we have?
I think about, so the last time I looked, I think it was about 30 to 40%. Obviously, we have a lot of customer with, you need to be certain level of code.
Yeah.
We announced that in 7.0, I think it was. So it's about 1 year and a half. So it was about 30%, 30 to 35%. I can't give you the exact number. But.
Yeah.
So, so this is just showing you the full lineup of the SC, the full family, right? So these are the two new children, like the 5020F, the 7020F. That's the Allflash family. We just announced it yesterday. And then this is basically our hybrid family. The V3 is the newest addition to the family. But what you'll see is that basically since the time we merged, pretty much everything across this family was refreshed, right? The 7020 came out immediately at the time of the merger. Then the 5020 came, the V3 came, right? And then now the 5020F and the 7020F, right? So pretty much the entire compelling lineup got refreshed, right? And that's the hardware. Just quick highlight some of the capabilities. So one, we talked about, so now across the family, pretty much all of these arrays have the same capabilities, right? In the past, if you remember, the SCV2 did not have all of these capabilities, right? So that's sort of, that was causing issues, so we fixed that. So apart from deduplication, which is not there on the V3, just because of the memory footprint and all that stuff, pretty much everything else is basically available across the board. So if you want a V3, put it in a branch office, and you want to do a 5020F in your main office, and then a 9000 as a backup, you can do all of that and replicate between all of them, and you can federate across all of them, and so on, right?
So I may have missed the point before, but is there any architectural difference between your hybrid and all-flash products? Are you using the same technology to address the way flash memory is being addressed?
So from a hardware perspective, yes. So from a hardware perspective, there is no change between the two products, right? So it's the same hardware. From the software perspective, most of the capabilities are same because we do want it to be able to replicate. We want it to federate among the all-flash hybrids. So most of the capabilities are same. Where you'll see changes coming in future, not right now, is that we might start putting in more optimization, right? So if we are not doing enough like tiering to hybrid, which is what we have done on the Unity side also, you'll see the code starts diverging at some point in time in the future.
So what's the difference between a 7020 and a 7020F if I decide to go with a 7020 which is filled with flash drives?
So one, right now, from a hardware perspective, as I said, it is similar. The software perspective, right now, the functionality is same, but only thing is, like as I said, from a packaging perspective, the 7020, you have to buy all the software separately. With the 7020F, all the software is included, right?
Okay. Yes.
Plus, then you'll see, like, for example, from a cloud perspective, when we offer the free cloud, right, we will be offering that free cloud only on the F family. This one will offer the capability, but the promotion is available only on the app.
So hang on. So right now, as of today, with the all-flash units versus, from a software perspective, from the hybrid that's been around for a long time, and the all-flash, there's been no specific data path code optimizations to this point?
Well,
that's where I'm heading.
No. So that you asked the right question, right? It's, if I have flash in the system, do we treat flash in a different way? That's, I think, what you guys asked. Yeah. Obviously, there's been a ton of evolution in that place. The code that we run is the same, but we already have people that they bind this in full flash, right? So, for example, the page size that we're gonna speak about, we optimize the page size for flash. Okay, it's 4K. The other things. On the hybrid, if you use an hybrid, if you remember, it was very hot at some point, the fast track capability, putting the things on the edge of the splatter. That is there only for hybrid. We have a technology now that we can expand and shrink a RAID group, and we try to do also, when it's all flash, we try to optimize the page size and the caching for that thing. So there is changing. Since 6.3 for optimize the system for flash. Now, if you fill this system with full flash, obviously you get that optimization. If you are in a hybrid situation, for example, we suggest 2 meg pages. The caching has been modified to be more compliant with the flash, right? The flash needs a lot of I don't need to spend time in cache sometimes with the flash. I'm doing, for example, full stripe write and all these things, right? And that's the work that we went in the code. Now, if you look at to your point, right? There is evolution in the code, obviously. It's not, and also we can, the other things that we did, we can differentiate from write intensive and read intensive drive. and we can use that in the system to optimize our cost
Yeah.
as well.
I mean, I go back in my memory to an article I think you wrote a long, long time ago, or a conversation maybe about, built from the ground up Flash versus changed to Flash later kind of stuff. And we've had these conversations over and over again with lots of different vendors, right? And we know which vendors we're talking about.
Yeah, but Compellent, first of all, started
Yes.
in the hybrid in a better position. And frankly, it's, the difference between a 7020 and a 7020F is packaging and making Joe Unsworth happy. Because if you buy a 7020 full of SSDs, Gartner doesn't count that as an all-flash array.
Right.
And if you buy a 7020F, they do count it.
No, I understand that.
And it's not just Gartner. I just want to address it there. We have had RFPs which would say that if this is not certified as an all-flash, I'm not going to buy it from you as an all-flash.
Yeah.
Well, that's
Well,
that's customers
I was
stupid
more
enough
going
to
at it from
believe
a latency
Gartner.
perspective, right?
Yeah,
Just that's my only perspective. Like we can do as many IOPS as we want, but at what latencies are we looking at? And
Yeah,
So
it's-
when we get to the technology and the architecture, you're gonna see why the latency is so good on this box.
Fantastic.
So we're gonna.
At what Piligo was saying about the flash optimization that we have done. So from the days of the hybrid, we put in all these optimizations. Now,
Yeah.
there was a choice we had to make that, do I make this optimization available only on the F or not doing it on the F? And the decision we did was like, let's not put artificial restrictions. So the code, so that's what Piligo was saying, like if you take the 7020 and fill it up with all-flash, you will get that same optimization,
act like an F, yeah.
that optimization that you have on the F side,
Yeah.
right?
It's also-
and it was a decision we had to make, should I restrict it or should I not restrict it? And we sort of went with the flexibility at this point in time.
Well, we thank you for that.
Yeah.
It's also important that we've reached the point where having come from a hybrid has advantages.
Yeah.
Because some of the guys who started as all-flash arrays with one tier of storage
Yeah.
don't have the logic for write-intensive disks and read-intensive disks,
Right.
which will reduce the cost. And next year, don't have the logic for NVMe.
Yeah,
and
you're right.
streaming disks.
Yeah, you're absolutely right.
And so you're-
and that's a very good point, right? I mean, we don't have a time to discuss this. We can discuss later, but I think you touch a point that is very important. Using multiple media and multiple media type in the near future will become very relevant. Who is gonna win? Is gonna win who knows how to build these things. Right?
Yeah, I've started talking about solid state hybrids.
Yes.
Where there's multiple media type, but none of them.
I use
fit.
hybrid in my presentation, like hybrid, and they say, no, you cannot say that.
Right.
So, but basically, the intelligent technology of place the data in the right place is going to become another big things in the near future.
Yeah.
Okay. So it's always is a circle coming back.
Yeah, we're already seeing from at least one competitor a system that has 2 tiers of storage and no logic for assigning data to which tier.
Yeah. All right. So
One
let's.
more point on the previous slide.
Yeah,
The
sure.
recover point for VM, is that
Yeah.
now included with the all-flash?
So recover point for VM, we have 2 bundles basically that is included, right? So for one for the small and one for the large, yes.
Okay.
Okay. So just showing you, so this is again like you can see the hardware here. I mean, so there are it's 2 controllers. So this is basically one of the controllers taken out, right? 2 controller boxes.
Pass it around.
Right. Yeah, sure. You wonder. Is it heavy? What is?
We're tough.
All right.
Go for it.
Why don't you keep it here? So 2 controllers. Depending on this particular one is the SCV3, so it doesn't have these additional IOs. So it has only 1 extra additional IO module. On the 7020, you will have 3 of them, right? IO modules. We also have built-in IO modules, right? So built-in 10 gig. IO modules also. All 12 gig SAS backend
Is that
now.
10 gig base T? Oh no, it's SFP.
Yeah, it's both basically
Either,
copper
okay.
as well
Either,
as
okay,
copper
good.
as well optical, right? And then these are the expansion PCI slots. So on the 7020, you have 3 of them per SP. On the 3000 and the 5000, you just have 1. Right? And you can see it out there. Right. Now that's on the hardware side. Now from a software perspective, actually there are two capabilities or sort of 2 architectures that I'm going to talk about. So one is basically this virtualized page pool. right? This entire abstraction of how I lay out my data set and some of the capabilities that is enabled by this technology. And then this concept of this virtualized front end, right? Which is basically the core capability behind things like live migrate, the live volume, and so on, right? So the virtualized front end and the virtualized page pool, those are the key architectural core basically of this product, enabling multiple features. And we're going to talk about each of these in depth. So let's start with the virtualized page pool. So the virtualized page pool offers these technologies. So one, basically, this is basically our tiering technology, right? Ability to move the data around, right? Efficient placement of data at the right level, at the right tier. Right now, you might be wondering if it's all flash, how does that matter? It still does matter in the all flash as well, and I'll walk you through that, right?
One of my complaints about Compellent historically has been the schedule on which you do progression. Used to be relatively coarse-grained.
Right.
How frequently are you moving data nowadays?
So there is by default, it's once a day, but you can move as much as you want, really.
It's right, on demand. You can do it on demand. It can do it automatically.
So I can tell it to do it continuously.
Yes. Right. It is on demand. It is automatic, and it is scheduled. So you can do all three, and we take advantage of all three. Right. Snapshots is built into the product, and I'll talk about it. And it gives you a lot of flexibility, and I'll show you, like, you can move snapshots between A to B to C. You can move everything around. Whenever you move moving a LUN from one place to another, snapshots automatically go with it. Right, so a lot of flexibility, gives you many use cases, opens up many use cases with this technology. And lastly, but not least, is basically this is also the core of our dedupe and compression logic as well.
Okay, and the dedupe and compression is post-process.
That is correct.
Which brings me back to the same. And what are my scheduling options for that? Because
so as I said,
you can get yourself in trouble with post-process dedupe on primary storage and capacity planning. Because
got the right speak. Boom.
You write you.
So hold that thought 1 second. When we go in the architecture, you're gonna understand there is an elegant way that SC use to define what is active and not active. So we have active page and read-only page. So we're gonna explain that.
Okay.
Okay.
I can wait. I'm almost patient.
Yes. It's 2 more slides, and I'll walk you through that thing. All right, so let me walk you through that. I mean, in fact, we can actually show you exactly how it works. So this is basically an all-flash system, right? I'm not even talking about hybrid, right? This is an all-flash, right? These are my all-flash drives, right? We create this virtualized page pool. So one first thing different you'll notice is this page pool, it does not map everything on the drives, right? It basically is that's why we call it dynamic, right? It allocates only what it needs right now. And then as you write, as you need, it expands, and it also shrinks, right? So that's one thing. The other thing you'll notice is that we stripe across all the drives, right? We try to maximize it. So this part is RAID 10, this is RAID 5. We will stripe it across all platforms so that we sort of maximize the IOPS that I can get out of this thing. So this is basically your initial state. You said, hey, let me create this page pool. We'll create enough for now, right? Rest of it is unallocated at this point. New IO comes in, writes come in, they immediately go to this RAID 10 tier, right? So that gives you the fastest response time, right? The fastest operation, basically the best response time coming, right, written to RAID 10.
Is there no longer an NVRAM write buffer in the system?
So there is a write buffer, but we recommend, like in this type of a situation, if it's an all flash, you don't need it. You can just go directly to RAID 10 and you might get faster because you don't have to do this 2 levels of writes, right?
Yes.
So then this concept of data progression happens. To your point, there are three ways when your data progression happens. One, basically you can set it based on a schedule. You can be based on demand. Every time you take a snap, immediately data is frozen and moved out here. And then the third time when it happens is when it's automatic, right? If it sees that this thing is getting filled up, it will automatically make sure that you take you do a data progression, move it out there. So it's automatic, scheduled, on demand, and you get all three, right? So every time you take a snap or whatever the reason is, we move this data from RAID 10 to RAID 5, RAID 6. During this move, when you're moving it, if you have deduplication and compression turned on, this is the time we will dedupe it, we'll compress it. And I'm going to show you how what really happens during that stage. Right? So it's not waiting till the end of the day to do dedupe and compression. It's as you move, at that time, immediately it does the dedupe and compression.
And the relative amount of space for the RAID 10 landing zone and the RAID 5 cold state data is dynamic?
Yes.
This is dynamic. That is absolutely correct. And I'm going to show you that as well, right?
Do you have a policy that you can actually pin certain writes and keep them permanently?
That is correct. So you could say that P3 is very important. I don't want you to move it to thing, though. So no matter what, we'll always keep it in RAID 10 then.
Okay. So how do you identify that? What kind of algorithms do you use to actually identify those blocks that keep them in the cache, or at least in the level that you are in?
So we use basically we look at the temperature and the access rate of the data, right?
Okay.
So we can freeze the data based on the pattern that we see a LAN. It's a logical and the LAN is basically a collection of LBAs, right? So that LBAs, they are attached to this slice, and the slice are attached. So you say, okay, freeze this slice here, and we freeze the slice over there. But to your point, I think before you said about the how we make sure that we not have impact in the performance, is because everything that you do in here in RAID 1.0, any read modify write happen here. And then I freeze the things again and goes down. This is shrink, this is expand, this is shrink, this is expand. And that's a very elegant way to do this. It's coming from the years of SC data progression. So it's a very elegant way to do that. But that's why, again, there are certain customers they want full inline. We have a box here. There are certain customers that they want the best efficiency, right? Because inline doesn't mean that you have the best efficiency always. If you look also at some of our competitors, they use background stuff also if they are inline, because they cannot catch everything. Here is very elegant, because I can actually divide the active from inactive. And if you look at the data decay model, right? If you have 30 days, when is the time when you write more? Is when you have the new storage. After 30 days, so your RAID 1.0 is basically expanding, but then after that time, you get more efficient every day.
Yeah,
right?
That's true.
So that's absolutely one of the key things here. Now, obviously, RAID 1.0 gives you the best performance, right? So there is a penalty there for that amount of time, but the system is so intelligent that can shrink and expand every tier. And the another things that you may not notice, you can have different RAID type on same disk.
Right.
So the physical disk can have different RAID type. So I can have a RAID 1.0 for this slice, and I can have a RAID 5 for the other slice. So in the data movement, data progression can happen. This is very good, especially when you have flash drives. You may have a lot of capacity there. You buy larger flash drives, but you can have these things working together.
Now,
You guys are staging writes in memory and then destaging, right? So you guys are collecting writes and putting them down, right? You're not all just going straight down to the RAID 10 with every write that comes in the system.
No, we have also a caching.
Yeah. So what I'm trying to figure out is what the benefit of the RAID 10 has. Why do you? Well, let me ask the question. What is your measured difference between writing to an all-flash RAID 10 stripe versus a all-flash RAID 5 or 6 stripe? To you, what's the difference?
So there is obviously a performance hit when you go from a RAID 1.0 to a RAID 5.
Well, if you're calculating it in memory as you're coming in, is there?
Well, there is a difference in the way when you do the XOR and then calculate the parity to make sure, and you have you are very sensitive to the latency, right? And you read and write everything from that. We want to use RAID 1.0. Now,
I mean, you're in cache though. That's what I don't understand.
Well, the cache.
Yeah, but RAID 5 if the write is smaller than the stripe side, it's still a read modify write.
It's an overwrite.
So the
Well,
read
read modify write.
So that's why I pointed out the read modify write. This is the key is when you have a lot of metadata and you have a lot of incoming data, right? And you do read modified write, then you need to compute and you do backfill in the cache.
Right.
So that's a very time-consuming operation.
Right.
If you're going down with the RAID 1.0, then you don't need to do that. And the fact that they can expand and contract every time, because RAID 1.0 is RAID 10. It's basically mirror pair, right?
There's no
every
CPU
time,
calculation.
and the fact that I can have the other ones that give me the efficiency on the other space, all the things here is to calculate how much RAID 1.0 I want, right? And it needs to be minimal for the incoming writes. So we have a tool for doing that. We have a sizing tool, and we say basically minimum, we say about 10% to 20% need to be in that space.
Okay.
That tier 1 needs to be 10 to 20%.
Yes.
Your support get really angry if you haven't got 30%.
Your support.
If you call up with a problem, and it is around Flash, if you haven't got 30%, your support will get extremely angry.
We speak about an all-flash array.
This is an all-flash. There is only tier 1. There is no tier 2, right? This is all. So within tier 1, what we are saying is that we split it up. So think of this like RAID. Part of tier 1 is RAID 10. Part of tier 1 is RAID 5, RAID 6, right? So it's still tier 1.
That brings the secondary question. Right now, you're saying it's all tier 1, so we're exactly the same flash profile for all the storage in these bays. I'm not getting like 12 NV. I can't do tier 0, tier -1 with an NVMe set of disks for my RAID 10 slot where I really want that performance.
Right. So what you're bringing up a good question. Yes. So right now we don't support NVMe. So but when we do, yes, that could become
NVMe will be part of these.
Okay, so we'll be getting our tiers back shortly once we, because right now we have one tier and it's just a logical dispersion with the type of RAID protection.
That is correct.
You have one tier with multiple RAID protection and with the ingest of inactive page that they do in dedupe and compression.
Exactly.
So you not sacrifice your incoming writes or read modify write for performance.
Right.
That's one of the advantage to use a background.
But the real benefit is going to come back when we actually do have multiple tiers with different performance profiles.
Absolutely. The other thing also to your point regarding the memory, right? Why we turn it off? Because if you write in a memory, because we're an active operation versus other guys who are active passive, we have to mirror the data, right, on the other side, right? With this, when you turn it off, you don't have to do any mirroring.
The less cache you have, the less cache you have to keep coherent.
Right. Yes. So we have to keep coherency and all that. So you don't have to worry about any of that. This is all. If a write is acknowledged, the power. If someone pulls the plug, I don't have to worry about anything. Right?
Yeah,
Everything is there.
It's also important to note we're talking about chunklet RAID, so it's not some SSDs in the RAID 10 and some SSDs in the RAID 5.6.
Yeah. Okay. All right. So let's move on. So anything which is moved out here, you can do all reads from here. But anytime, say, if you want to do a write, that even if you want to do a read, modify, write, it comes in as a new page. I don't want to modify it. It comes in as a new page. The progression will take care of it, right? So even if it's like deduplicated, you will uncompress and undedupe to read it. But when you write it, I won't go back and try to fit it in. I will go immediately out here, write it there, and my next progression take care of the deduplication again, right? So P comes it out here. Now, as you can see, this particular page is being now replaced with this page, right? So the snap is pointing to these blocks. The LUN is now pointing to P5. It is no longer pointing to P3 because that's the newest version, right? So if you delete the snap, automatically that gets freed up, right? And then we can give the space back, right? And then, like as I said, this pool is sort of growing and expanding and shrinking, right? So if it needs more space, it'll just go and automatically allocate more space, and then if it sees that it has too much space, you're not using as much, it will free it up and give it back, basically. Okay, so I'm moving to the other part of it. So snapshots, as I said, as I showed you, is sort of ingrained. That's part of the technology built in out there. So our snapshots are all readable snapshots, right? So if you want to write it, you mount it as a volume. We call it a view volume, right? You mount it as a volume. You write it. It now becomes like almost like a separate LUN, even though it's sharing the same space. You write to it. You can have its own snapshots. So it basically behaves like almost like a separate LUN, but sharing the same data set, right? You can then set up a sync. I'm showing you all multiple use cases. You don't have to implement all of them, just showing you the possibilities. So you could have a sync replication setup where you have these snapshots are going to a sync site. If you so choose that you want to have now branch offices where you want to send it out, and you can then take that volume and send it out along with the snapshots to that site, right? So in case there is an issue on the branch office, they could just quickly recover from that snapshot. You could also have another backup site where you can keep snapshots for a longer duration. So you could think of this like an Allflash where you keep like 7 days worth of snaps. You can have a remote site, DR site, where you would have like probably 100 days and more of snaps. And then when we have the cloud, for example, you can then think of this as another tier behind this where you could create 5 years worth of snaps. Right, so 5 days, 5 weeks, 5 months, 5 years, whatever you want to keep it, right? So as you can see. And so what you're showing you basically is that it's a very flexible solution, right? I'm just showing you a lot of use cases. You don't have to implement all of them. Based on what you need, you can pick and choose the configuration that works best.
On the snapshot retention policies, where does that get defined? Does that go, is that the volume has that? Obviously, it's specific to where it's living at a moment in time.
Right.
Do I have to specify on this bay or this storage system, this is my snapshot retention policy? Or do I go to the volume and say, here's all the places I will find it, and here's the snapshot policy?
Right.
You might be showing that in the UI, I think, is more what I'm trying to figure out. Where do we?
Yeah, so the snapshot policies are defined on a per volume basis, on a per system basis.
Okay, so you see both very.
And we can, and certainly it's not uncommon to see many different types of snapshot policies based on the different workloads that would be on a shared storage system. So separate policy for each, or a separate snapshot policy for each volume, and any given volume can have more than one snapshot policy. Right. So we can start to stack, not only the times that they're snapped, but the retention as well.
So the moment I declare a replication policy, it will give me associated snapshot retention policy along with it.
Can you restate your question?
So I'm starting from my primary volume. I declare a synchronization policy somewhere, async or synchronous. And once I've declared that replication policy, the next option will be, and once you've got it over here, what's the retention policy associated with it?
So the retention policy for the destination replica will follow the snapshot policy from the source. Now we're not going to snapshot the replica because the source is the source of the snapshots, and as the snapshots are taken, those frozen snapshots are replicated over, and then on both on the source and the destination, they will roll off as the policy states.
Okay.
I think to answer the question very basically, I think we if I understand, we move the policy. The scheduler, it's going to be propagate to the other one, or the policy, whatever.
And then you can modify it on the other side. So when we replicate it, we'll carry it forward, and then you modify it and say, okay, I change it here, and now
I think I'll be more interested in seeing it up on the UI when we
you can
get in the demo.
Okay. And then the last piece of this virtualized page pool is the dedupe compression. So this is what I was showing you when the data progression happens. We move it from RAID 1 to RAID 6. While we are moving it during this process, while it is in flight, that's the time we do the dedupe and compression, right? So what really goes on in the behind the scenes, just a very high level. Our page sizes, by the way, if we remember, is 2 megabytes, 512 KB. 2 megabytes, right? So from a dedupe perspective, that's too big, right? So what we do is we immediately slice it into 4K blocks. So that gives you very granular deduplication. We slice it out, we fingerprint each block, we look up in the dictionary, yep, it matches, we verify it, we immediately remove those 4K blocks. So it's a very granular 4K block deduplication, right? So take care of that. So then once we have taken out those 4K blocks, then we do compression. Now compression works better with the bigger blocks, right? So dedupe works better with smaller blocks, compression works better with bigger blocks. So what we do then is that we take these 4K blocks, the unique blocks, we pack them into 64K blocks. And then we compress those 64K blocks. We compress those 64K blocks, and then we try to create a page, because everything's stored as a page, right? We read 2 pages here, we did compression and dedupe, created a new page, and that's the page we write down, right? So just during this process, all of these things happen while this is in flight, being read from RAID 10, written to RAID 6, RAID 5, RAID 6, whatever. Okay, so that's our deduplication compression logic. So a couple of benefits. One, very deep right? As I said, right, can give you, depending on what your workload is, 3 to 10x efficiency. As I said, you can make it work for all flash, you can work for hybrid, right? Doesn't matter, right? If you're doing reads, as I said, reads happen from here, so the deduplicated page will get read, and then the original page will get reconstructed in memory and sent back. But when you're doing a write, it gets immediately written out here, right? So we don't try to do that in memory. And then, like as I said, minimal impact to performance with this technology today. So that was the virtualized page pool. Now I'm just changing gears a little bit and going to talk about your virtualized front-end capability, right? With the virtualized front-end, we get three capabilities that we get with this technology. One is online data migration. We call it Live Migrate, right? Our online intelligent rebalancing, that's Volume Advisor, and then online disaster recovery, that's Live Volume. That's all enabled by this technology, the virtualized front end. So let's walk you through each one of these. So this is online data migration. This is our live migrate, how it works. So here's a volume, right, mapped to a host, right? You choose to do a migrate. Now there are two options to do the migrate. There is an automatic and there is a manual. So I'm showing you the manual one first. So you say, hey, I want to do a manually migrate. So this is a migration use case, right? You had an SC8000. You now bought your SC5020 flash. You want to migrate this LUN from this array to this new array, right? So we'll say, hey, I want to do a manual migrate from A to B. When you say that, we will automatically set up, create a LUN. We'll start the replication. We'll give you a choice if you want to use an existing LUN, if there is an existing, but if not, we will create a new LUN, same size, set up the replication. This is all happening under the covers. You select, and we'll show you as part of the demo. You just select yes, and we'll take care of all of these things. Then you can map this LUN to the host. So the host basically sees two paths, but it actually, to the host, it thinks that as if there was a second path surface for the same LUN. So from the host perspective, it sees one virtual LUN. It's not seeing two LUNs. It sees one LUN with two paths, right? So it can do round robin IO across both, right? And we'll take care of making sure, but there's still a primary, so all commits are happening at the primary, right? And then once all the data is out here are in sync, we'll give you an option saying, hey, the two LUNs are now in sync. Do you want to do a cutover? So when you say, yes, I want to do the cutover, that's the time we flip the roles. So this becomes source, this becomes target. Host doesn't see anything. It still continues to use the two paths, right? No changes, right? And then when you so choose, you can then cut the cord. So everything is online, and then Jason is going to do the demo. So everything is online. You can do it from any SC series to any SC series except the V2, right? When you do move the LUN, we can move the snaps, we can move the replication sessions, so there's no impact from a DR perspective. So if this was protected to a third site, that all moves over when you move the LUN.
So this is only, you get this when you buy the Allflash series, right?
So this technology is available on the hybrid and the Allflash.
Yeah, I know there, but for
hybrid,
one you have to.
For hybrid, it's a separate license that you have to buy.
Yeah.
For Allflash, it's included.
And if I want to migrate from an hybrid to an Allflash,
you can use.
Can I use it?
Yeah.
Yes.
Okay.
Right. You can use this technology. Yes, absolutely. Okay. Simple, easy to use. All right. So that's migration.
In that example of wanting to go from hybrid to all flash,
yes.
So the hybrid's the old legacy system and moving to an all flash. Do we have to go back and license the hybrid system for the migration to allow us then to get to it, or is it just because we've got it on the flash system that's enough?
No, you need a license on each array that needs participates in it, right? So if you don't have the license, you'll have to buy it. That's correct.
So could I buy an Allflash and then buy a shelf of disks? What will my licensing situation be there?
Yes, that is correct. You can. So I think what you're asking is the license based on capacity? The answer is no. Right. You can buy as much capacity as you want, and the license is applicable to all.
But we're saying that the Allflash came with the full licenses. So if I look at the Allflash and I go, this is great, but I'm starting to accumulate lots of cold data.
Yeah.
I don't want to buy a full flash shelf at the back end of this. That would be cost prohibitive and not really useful. And
you can
absolutely.
So I can take that and throw a 30-disk shelf of big 10 terabyte drives and go, that's my cold data. It lives down there.
Right. you can add it here. If you didn't buy an Allflash, it'll add you there, and you can do data progression.
Yep.
Or you could add it to another array and move the LUNs to that array, basically. So you can do that as well.
Okay.
Right.
So, yeah, just because the biggest problem I'm seeing, and I think we're all sharing the question, in an all-flash array, the value proposition of data progression has not disappeared, but it has been severely limited.
Right.
So the interest is, I want to buy this to front all of my hot data, but I'm still going to keep accumulating cold data, and all the value add would really be the ability to keep adding. I mean, most people will usually end up with fairly static workloads.
And by the way, that's where the volume advisor and the federation come in place as well.
Yes.
Because as we said, you can monitor that by capacity as well, or performance. So you can move stuff out when you need to these cold
data stores.
But
I'm still looking at your value prop at the beginning was always, I don't want to have to move it. If I've got an array that can handle my volume, it's so much more interesting. Just I have my two or whatever I got for my disaster recovery, but I just keep adding cold data at the back end for the accumulation because I've never been able to find a way to build an archive policy on my file servers that anyone will follow. So I just keep having cold data sticking around forever. But I only have a certain amount of truly hot data, and it fits inside this flash shelf. So this is perfect. And I just want to keep stacking more disks until I fill the thing up, and you guys give me the next generation.
Right. Oh, good to that.
Yeah.
What sort of latency can I expect out of this? I mean, you quote IOPS, but you don't quote latency.
So
on the system, not on live migration.
Sorry?
On the system, not on live migration.
Yeah.
We're not talking about the slide. We're talking about the system.
The latency during the migration, you mean?
No.
General.
No, you say
you quote 399,000 IOPS, but you didn't quote.
Oh, okay. So
Any
sub-millisecond
figures?
on an all-flash, basically, that's basically the standard nowadays, right? So sub-millisecond response time. So that's basically what we offer you with, not at 399,000, I'll have to look it up, but yes, with sub-millisecond response time you do get with that all-flash.
So we did some tests with the data progression and everything. You are most of the time under 1 millisecond, right? And obviously not with the 399,000. I don't remember out of my head how much was, but the goal is to stay under 1 millisecond. When you have data progression, it goes to probably 1.3, and then it goes down. Depends how much data you need to move.
Okay.
Yeah. All right. Now this is
the things that, as I said before, right? The real advantage is the read modify write. So everything that you do in read modify write, you need to pay a penalty there. So the fact that you're not doing that give us actually very good latency on that tier one. So that's.
I'm not too worried about how you're doing it. All I'm bothered about is what latency am I getting for the price I'm paying.
Oh yeah.
So if you're giving me a better value,
yeah,
by doing that under the covers.
No, I got yeah. We have the
comes down to cost and what I'm getting for it.
Absolutely.
All right. So that was basically a migration use case. This is basically the same technology, but now applied in a federation use case, right? So basically, I have now in this example, I have 6 arrays, right? Even though the pictures show identical, but they can be all different. And in the demo that we're going to show you, it'll be all different, right? So it could be a V3000, it could be a all flash, it could be a hybrid, it could be an 8000, doesn't matter, right? So you take multiple SE arrays, put them under one federation, basically, right? Volume Advisor is on the Dell Storage Manager, right? So it's monitoring all the arrays. These are some of the areas that we are monitoring. So you can be based on CPU utilization, it could be based on response time, it could be based on system capacity. You decide what you want. So you could say, for example, in the demo that we're going to do, we will do it based on response time, response time or CPU utilization, one of them. Latency, yeah. So from a latency perspective, we'll say, hey, if the volume shows, you can set the threshold. If it shows above this response time, give me an alert, right? So it will not only give you an alert, it will also give you a recommendation, because that's where the intelligence comes in. Because giving me alert is great. Now what do I do with it, right? So it will also give you a recommendation, and that's where the intelligence part comes in. Is it'll give you a recommendation and say, hey, it's crossing the thresholds that you wanted. Now I would recommend that you move this LUN from this particular array to this particular array, right? Now if you most customers take that recommendation and say, yep, I like it, click OK, we'll move the LAN. If you want to change it or do something different, then that's also optional to you.
So basically it's storage DRS at the array level.
Right.
Yes.
Yeah, exactly. So that's basically, so you get a thing, it gets an alert, right? You'll get the recommendation, you take the recommendation, we'll use live migrate, which I showed you earlier, that same technology, move the stuff, and then hopefully you're back, your situation is normalized. Right, and this is the part where we are going to do the demo. So we'll give you a live demo of how this thing is working.
Is it fully automated? Or what's the policy on the migrations?
Yeah, so you can set the thresholds or yourself, right? We will give you the recommendation, but we will not move it for you, right? We'll just give you the recommendation, and then you decide, you click the button and you're saying, yes, I like the recommendation, move it. Or if you don't like the recommendation, you say, oh, it may be recommending A, but you say, no, A has some very critical applications. I don't want to move it to A, I want to move it to B. You can.
And this is all available through the REST API? So if I wanted an AI at the back end to make the decision,
that was an interesting point that you brought up. I was just going to talk about the API. So we've got a public API which supports both REST and PowerShell. And although it is manual, right, we'll provide, Volume Advisor will provide the recommendation. At the end of the day, the administrator needs to evaluate that and then carry forward. What you bring up is interesting because the way I think about the API, if it's in the public API that we offer, build a script, whether it's REST or PowerShell, to at any given time on a scheduled interval, evaluate recommendations made by Volume Advisor and automatically, and maybe you put some conditions in there, but automatically carry through, for fully automated storage DRS, as you brought up.
So I can get my own script that will push the button for me.
I say it's interesting, and I'm assuming it's going to be a public API.
Yeah.
So hold your thought on that. My next slide is going to address that situation. So if you want fully automated, right, if that's what you want, right, I don't want to press a button. I want the thing to automatically move it, right? Say, for example, typically this would be a situation where it's a mission critical application, right? Say something goes wrong in the middle of the night, you're sleeping. You don't want to be, you are not there to press the button and saying move it, right? So this is basically our live volume technology comes in. So if that's a mission critical application and you trust the system to do the right job for you, right? Because it's absolutely critical that the thing is up all the time, even when you're not there at your desk, then that's the technology. So in this case, again, if we have time, we'll do this demo also. So in this case, basically, again, the same underlying core. So you have the volume. It shows up as a virtual volume to the LAN, so it sees both paths. You have a sync replication. So if you want to do an automatic failover, we recommend it has to be a fiber channel link with a 10 millisecond response time, right? You could potentially have also
be fiber channel.
Can't be iSCSI?
If you want the auto failover, if you want that automatic failover, then it has to be a fiber channel. We support iSCSI also for the link you're talking about, right?
Okay, so the replication link has to be fiber channel, but the presentation layer could be iSCSI.
Not correct. Fiber channel or iSCSI or both.
Yes. Okay.
Right.
Okay, great.
Right. So this is the response time that we need. Then there is a third site. We potentially, if you want, so this could be like within a metro distance, and then you could have a third site where you can replicate, which could be an async replication happening, right? In case both of them go down, then you can restore from there, right? So in the middle of the night, if a disaster strike, this array goes down. If you have set up the auto failover, then automatically we will move the LAN, we will move the snapshots, everything automatically fail it over to this other array while you are sleeping, right? Everything happened, right?
If you've got a 10 if you're going like 8 or 9 milliseconds latency between those two sites, you might as well get a hybrid array because there's no point having all flash at that point.
Yeah, so that's the max of what I'm saying, right? You don't need to keep it that way. It could be less.
I mean, that's the max of.
Right. If you're going in that environment and that's what you got, save yourself some money, buy yourself a hybrid flash.
Never say that to guys trying to sell stuff.
So that's your maximum. You don't have to go there. So we do the automatic failover. Next morning you come, you fix the system up. When you bring the system up, because if the LAN wasn't destroyed, you can do an incremental attach. So you don't have to send all the data back. Only the data that was written during the night. You only do an incremental attach, so it gets recovered pretty quickly, right? And then it's restored. When it gets restored, this comes up as your secondary. That still stays as your primary. So you can operate in this mode. You don't have to fail back right? But if you do want to fail back, it's an optional step. You can again do a fail back and bring it back. If you want this to be the primary always, you can do that, and that's optional entirely.
Okay. So when I'm in this metro, this is basically metro clustering,
That is
standard drill.
is exactly.
When I'm in this configuration, my host is seeing 2 paths as being live.
Yes.
I see.
They're all, well, more than 2 paths in most
yes.
cases, but
Right.
they're all going to be active. And
Okay.
today,
And if I send I/O to the passive or the non-live copy, does the bay route that I/O back through, or does it say, "Don't talk to me, I'm not really here"?
no, it never says don't talk to me. So we want, in order to pull off stretch storage and also, pass the vSphere Metro Storage Cluster certification, which we did.
Yep.
What you call the passive, we call it the secondary live volume, okay, in the architecture. That is a proxy device to a storage host, VMware or any storage host that will support live volume. It appears as a readable and writable volume. So feel free to send it read IO, write IO.
Okay.
But if it's going to the proxy, that IO is forwarded through the replication link, whether it's fiber channel or ISCSI, back to the primary live volume. If it's a read, the data payload is fetched and sent back. If it's a write, it's committed. The acknowledgement is sent back through the proxy to the storage host, and then in turn replicated synchronously back to the secondary, so that we have synchronous.
So I do want to pay attention to my site preference assignments in those cases, so that I'm not in a case where I'm trying to use the paths for my secondary as...
Yeah. You don't want to redirect all the...
Yeah, because I'll be doing a lot of back and forth extra traffic.
The path selection policy with respect to this architecture brings up a lot of interesting scenarios on what you might want to do, what path selection policy you might want to use, fixed MRU, round robin, and so forth. Alua comes into the discussion.
Yep.
Whether you're uniform or non-uniform, storage presentation comes into the discussion.
Yep.
You're absolutely right. You identify that as there are optimal paths in a round robin uniform, and there are available non-optimal paths.
So I have to...
in terms of performance.
So from a design perspective, I have to pay some attention.
Pay some attention. I can say that in the future, it's going to become, with the Lua support, obviously that would be really easy.
So we are introducing the Lua support.
Okay.
So at that point, we can automatically advertise the path, the
preferred
SCSI
path,
3 protocol, right?
Yeah. So if you are in uniform, and you want to use round robin and alleviate the management overhead of defining all your paths on your fabric, you would then be able to use round robin in a uniform configuration. In the secondary live volume, the passive volume will advertise its path to the storage host as available non-optimal. In other words, they'll have a higher cost.
Right.
Round robin, at least VMwares and also Windows, will ignore those paths until such time all optimal paths are gone or dead or not available.
Okay, that's good to know that's coming.
Yep.
Yes.
Cool. All right, so transparent between any SA, it's all the same things applicable. Right? Again, we'll we'll show you all these things.
And I think one of the things that we need to remember, that's what allow us to support stretch cluster.
Yeah, no, it's just wondering exactly how it's done under the hood. Some are active-active, this is an active-passive with the proxying notion.
Right. So you can use live migrate to move between the SC arrays transparently. We also have a technology called thin import that allows you to migrate from other arrays beyond the SC family. So it could be a EcoLogic, it could be a MD series, potentially it could be any array. It doesn't have to be these two, right? These two are what we qualified, but it could be pretty much any array, right? So, and that's all built into the product. Right, and as you can see, it can move all these LUNs into this array. And then lastly, but not least, we touched upon this a little bit, Cloud IQ. So Cloud IQ is basically our cloud-based monitoring analytics. We have built-in intelligence there that actually looks at the array and can provide you with recommendations, right? Machine learning type of thing, right? So, and that's also again included as part of the base array license, right? You just have to sign up and that's basically ready to use, right? We offer it on the Unity, extending it now to SC.
That hybrid and Allflash, or just
hybrid and Allflash? That's correct. That's right. Right, so that's Cloud IQ, single pane of glass for monitoring. The other cool advantage with Cloud IQ is that you don't need a VPN, you don't have to install anything. You are traveling wherever you are, as long as you have an internet connection, you have a laptop, a tablet, whatever it is, you just log into the Dell EMC portal, and you are able to see all your arrays across all your data center, all your mid-range arrays in all your data centers on that pane of glass, right? It'll give you alerts, it'll give you performance, it'll give you capacity utilization. If there's an error, it'll give you those alerts, everything you get in one place, right? And then we will bring in the HTML5 based Unisphere very shortly on the SC, similar to what we have on the Unity. And these are some of the other integrations that's already built into the product today. Okay, so if you don't have any questions, I want to now flip to the demo. I want to make sure we have enough time. Yes, please.
Data at rest decryption. It was included in the license?
Yes.
Is it enabled by default?
So data at rest encryption right now on the SC series uses external key manager, right? So the license is included, and if you have to turn it on, there is you have to buy these special drives, right? The SED.
Okay, yeah.
Drives, right? And then you have to also buy the external key manager. So it's not internal key manager. So you have to turn it on, you have to set it up to use it.
What's the performance impact if you enable it?
There's no performance impact.
No.
Yeah.
Okay.
They're set drives, so
Yeah.
the encryption happens at the side. Actually, most of the dry industry now, they are enabled for encryption.
Yeah, because the VMAX enabled it by default and didn't even give me an option.
The difference is on the Unity side, we have there inside of the controller.
Yeah.
So we not need to use set drive. So there is a difference there, but same results, right? You don't need to. You don't have a performance input. One requires external key manager, the other one does. So it depends what is the use case.
Okay.